Now I'd like to introduce the NCMA's director, Dr. Valerie Hillings, who has a few words for you and who will also introduce the NCMA's curator of ancient art. Welcome, Dr. Hillings.
Good afternoon, everyone. It's so exciting after missing last year to be able to host the Weinberg Lecture of Egyptology. We're so grateful to the generosity of Dr. and Mrs. Weinberg, who made possible the series of Gerhard L. Weinberg endowment-funded talks. And it was established in 2012, so we're well along in the history of this important series, and it really is one of the most well-attended at the NCMA. And I'm certainly going to, so I'm looking at the numbers on the screen now and knowing how many of you are with us today, so excited. This is an exhibition that was selected to go with the exhibition that Maria was talking about, Golden Mummies of Egypt, which opened this weekend to a sold-out crowd, and we're really excited about the show and about all the ways in which it introduces layers of the history of Egypt and also its connections to other parts of the ancient world. And this is no surprise that it was the idea of our great director of research and curator of ancient art, Caroline Rushlow, to bring this show to the NCMA. It was one of the first things I talked about with her. And of course, she likes to say, as she likes to say, she's known as the Egyptologist. And I'm so happy that she's got this wonderful show to share with all of you. And also the opportunity to bring great scholars like Dr. Zimmerman to help us learn more about this important subject. Through Caroline's scholarship over the last 15 years, she's made our small but coherent and wonderful Egyptian collection known throughout the international Egyptological community with the publication of the museum's first catalog of this collection. Through great programming and exhibitions, she's keeping the interest in ancient Egypt alive and well in North Carolina and beyond. I'm very excited now to turn it over to Dr. Rushlow and to Dr. Zimmerman, and I hope you enjoy today's Weinberg lecture. Caroline, thank you.
Well, thank you very much for the lovely introduction, Valerie. And I would also like to reiterate my gratitude to the Weinbergs. As the NCMA Egyptologist, I am most grateful for having this fund established exclusively for ancient Egypt. So thank you very much, Gerhard and Jan. This year, because of the pandemic and the fact that the Weinberg speaker is joining us from home, the funds made it possible to support 2 additional virtual lectures related to ancient Egypt. In mid-February, Dr. Campbell Price of Manchester Museum gave a teaser talk about Golden Mummies of Egypt. And Dr. Price will give another lecture on April 17th on Flinders Petrie, the archaeologist who discovered the gilded mummies. Today's Weinberg Lecture of Egyptology is related to this exhibition, as Valerie mentioned. And ever since I started at the NCMA more than 15 years ago, people have been clamoring for mummies, asking when I was going to bring a mummy exhibition to the museum. And this is because we do not have any human mummies in our own collection. Well, this time is now. Finally, after 15 years, we are bringing with Golden Mummies of Egypt 8 wonderful mummies. And as we invite visitors to explore the religious beliefs and hopes for the afterlife at a time when Egypt is ruled by the Macedonian Greeks and later the Romans. And it was actually important to me that this exhibition included mummies that were still fully wrapped and still adorned with all the necessary trappings, including the mummy masks and portraits. Even the interactives that allow visitors to see underneath the wrappings show only the image interpreted and created by the 3D digital scanner. So you never actually see the remains themselves. You see the final product of this important ancient Egyptian ritual. The mummies in the exhibition were studied with non-invasive technologies, but the examination of Egyptian mummies in the last 100 years or so was conducted also with more traditional methods. Today's speaker is an expert in the study of mummies, and he has even examined some mummies from Manchester Museum. Dr. Michael Zimmerman obtained his doctorate of medicine from the New York University School of Medicine. He also has a PhD in anthropology from the University of Pennsylvania and has a certification in anatomic and clinical pathology from the American Board of Pathology. His very extensive vitae lists teaching positions at different universities, including Villanova University, the University of Pennsylvania, and even the University of Manchester in the UK. His publications are far too many to list here, but include articles, books, and other contributions like Mummification Styles as a Guide to the Dating of Egyptian Mummies, Experimental Study of Mummification Pertinent to the Antiquity of Cancer, Unraveling Medical Secrets of Mummies, and my favorite, My Patients Were Mummies. Today, Dr. Zimmerman will talk to us about how we can learn from ancient Egyptian mummies from a medical point of view. Mike, the floor is yours.
Okay, thank you. And I unmuted myself, so I trust everybody can hear me. Good. Well, I'm going to start by just a kind of a little introductory stuff. I'm a retired pathologist now, but I'm teaching I teach medical anthropology at Villanova University, and I'm a consulting scholar in the UK for the K&H Center of Biomedical Egyptology at the University of Manchester. And one of the first questions that always comes up for me is, how'd you get involved in all of this? I had finished my training in pathology at NYU, actually at Bellevue Medical Center, and this was 1968. And in 1968, all doctors had to go into the Army. This is the middle of the Vietnam War, and the requirement actually for a doctor to be taken into the Army was that your heartbeat and respiration had to be spontaneous. So we all went into the Army. I was very fortunate. I didn't go to Vietnam. I was able to be stationed at the Walter Reed Medical Center, in fact, at their research institute, and spent the next 2 years trying to develop a vaccine for malaria, an effort that still hasn't really been successful. And it's kind of very similar to what we're dealing with right now. It's the malaria parasite keeps changing its identity, and that's why it's hard to develop a vaccine. And now we're dealing with a question of these variants with the coronavirus. But what happened when I was at Walter Reed really changed my career, because we had a medical student that came. He was in the Army ROTC, Reserve Officer Training and Program, and he was interested in mummies. He was from the University of Mississippi, and there was an Egyptian mummy in a museum there, and he decided he wanted to examine this mummy. So they, being very scientific, they x-rayed it first, and it was a fake. They opened it up, it was all made out of wood and plaster of Paris, had an 1898 issue of the Milwaukee Journal stuffed inside it. So he was very frustrated. He came to Washington for his summer active duty reserve, for as part of the reserve training program. And he went to the Smithsonian, and he was able to procure a mummy, not Egyptian, it was from the Aleutian Islands. And that mummy was brought up to Walter Reed. My colonel asked me to take over basically the examination of this mummy, because this fellow was a medical student and didn't have much experience in doing studies of modern bodies, let alone ancient bodies. Oh, I'm sorry, hold on one second. Sorry. And we did a full autopsy on this mummy, and we found that he was a middle-aged man who had actually died of a certain type of pneumonia called Klebsiella pneumonia. It's a pneumonia that's associated with, in modern times, with people who pass out in the street, usually from alcoholism, and get pneumonia and die. And he had some other diseases. He had some hardening of the arteries and a few other odds and ends. And we wrote a paper about it. And I came home and I said to my wife, this is a great field that I've just discovered. It's called paleopathology. Now, at this time, I was a fully certified pathologist dealing with modern humans. And I'm sorry. And I said to my wife, who had supported me all through medical school and a residency, I think I'd like to go and get a PhD in anthropology. And how hard could it be? It'll be quick and easy. I've gone through my medical school training and all my pathology training. And then Egyptologists and anthropologists will beat a path to my door and ask me to examine bodies that they're finding. Well, the first part, the quick and easy part didn't happen. I was working full-time at the hospital, University of Pennsylvania. So it was 6 years before I got my PhD. The part about beating a path to my door, that has happened. I've been to Egypt 3 times with archaeological expeditions. I've done a lot of work in Alaska because they find frozen bodies there periodically. In fact, last year I took my family to Alaska, and we were on the train going from Denali, Mount McKinley, down to Anchorage. And the guide on the train said to me, "Oh, is this your first time in Alaska?" I said, "No, it's my 7th." And she said, "Oh my goodness." I said, "Yeah." I wound up, to make a long story short, I wound up giving a lecture on the train. So it's been an incredible career, and I've really enjoyed every minute of it, and it still am. And as I like to tell people, all I ever really want to do is teach in college, and that's pretty much what I'm doing now. But let's go back to the topic of the day, and that's the study of Egyptian mummies. And mummy studies at the University of Manchester, and I'm sorry, the title of my talk is about the program at the University of Manchester. So mummy studies at the University of Manchester date back to the year 1907. So these studies go back to 1907, when Dr. Margaret Murray undertook one of the first interdisciplinary studies on 2 Middle Kingdom mummies at the Manchester Museum. They're known as the Two Brothers, and they were systematically unwrapped and dissected by specialists in the field of biochemistry, chemistry, anatomy, and textiles to produce a detailed physical examination that accompanied the archaeologic study of their tomb assemblage. Sorry about that. Oh, there we are. Somehow it went. Okay, we'll get through all of this. Sorry. So this is the 2 brothers at the University of Manchester. And I lost that slide altogether. And these were, as I said, it started the whole program of Egyptology at Manchester. Okay, sorry, technical problems. Okay, so here are the 2 brothers at the University of Manchester Museum. And this is Dr. Margaret Murray, who did this unwrapping in 1908. And okay. And this area of research was reinstated as the Manchester Mummy Project in 1975 by Professor Rosalie David, who's the person on the left. And the one on the right is Howard Carter's second cousin. I'm getting moved. All right, now we're ready to start. And Audrey Carter is Howard Carter's second cousin, and you may well know that Howard Carter is the discoverer of Tutankhamun. And they started studying the other Egyptian mummified remains at the museum, followed by establishment of the Ancient Mummy Tissue Bank in 1997, which collated the study of mummies in museum collections. And in the years following these studies, techniques for researching mummified remains have really improved. We now utilize CT scanning and directed biopsies, and physical unwrappings have largely become a thing of the past. To further such research, the K&H Center for Biomedical Egyptology was officially opened in 2003 by His Royal Highness, the Earl of Wessex, and this was designated a Center of Excellence in 2004 by the University of Manchester. But why is the study of mummified remains of importance? Paleopathologic examinations add the crucial dimension of time to our understanding of the evolution of diseases and their role in human biologic and social history. And information on ancient disease patterns can be obtained from ancient pathologic material and several other sources. Our concept of the distribution of disease in populations in the past is based primarily on historic records, such as Egyptian medical papyri and the studies of the role of epidemic diseases in the decimation of the indigenous populations after European colonization of the New World and Polynesia. We also have accounts of the great plagues of medieval Europe and epidemics in the more recent past. Before the current pandemic, talk 100 years ago, remember there was a great flu epidemic. Works of art, including such diverse media as paintings, pottery effigies, figurines, and religious statuary, and even figures and faces in coins, often give information on disease. But the examination of skeletal material and mummies yields the most reliable paleopathologic information, paleo-old pathologic study of disease. But the study of ancient and modern disease is not without its pitfalls. Skeletonization may be an erratic process, and pathologic changes may be obscured or obliterated by the vagaries of preservation. Pseudopathologic changes can be produced by erosive forces or anthropophagic animals that eat people. And most diseases leave little or no direct mark on the bones. Lines of arrested growth occur in bones. These are called Harris lines. And it's where dense bone is laid down, but the bone doesn't grow. And these have been suggested as an index of morbidity in a morbidity meaning disease in a given population, either modern or ancient. But Harris lines can disappear later in life, and they can result from trivial subclinical infections or even vaccinations. So they're useful only in a very general sense. Mummies, defined as bodies preserved either naturally, and this is by freezing, drying, or tanning the bog bodies that are found in Europe, or artificially, like our Egyptian mummies, hold a much greater potential for paleopathologic examination. Relatively standard postmortem studies can be performed on mummies. While loss of the features of color and consistency, so useful in examining fresh tissue, limits the interpretation of gross pathologic change, the tissues can be rehydrated and sections prepared for microscopic examination. Studying Egyptian mummies in the early 20th century, a British physician, Sir Marc Armand Ruffer, developed his eponymous solution, Ruffer's solution, which is water, alcohol, and sodium carbonate. This is very effective in rehydrating mummified tissue, although poorly preserved tissue tends simply to dissolve. And light and electron microscopy, very high power microscopy, can demonstrate remarkable preservation of normal and diseased structures. In the modern laboratory, fixation is accomplished by immersion of the tissue in a liquid chemical fixative, usually some variant of formaldehyde. Rapid fixation results in good preservation. Usually, excuse me. In contrast, mummification is based on enzyme inactivation by heat or cold, usually combined with desiccation, drying. This process is often erratic and is anything but rapid. Classical sources describing a 70-day period of mummification in ancient Egypt, as we see in this depiction of the first pathologist, the god of embalming, Anubis. The inevitable result is a degree of tissue destruction, which is referred to as autolysis, self-destruction, that can obscure pathologic change or even underlying tissue structure. But if the rehydration is successful, the specimens can be processed and stained according to standard histologic procedures. You can actually produce glass slides and examine them with a microscope. A variety of special stains can be used to demonstrate specific features of the tissues. In general, connective tissue stains, connective tissues, and any foreign elements such as pigments or bacteria or even parasites are best preserved. And this is the egg, the ovum of a parasite that's still very common in Egypt, Schistosoma hematobium. And there are several species of the schistosomes, and they're just differentiated by the spine, and hematobium has what's referred to as a terminal spine. In spite of all these cautions that we've just mentioned, diagnoses of many conditions can be made with a considerable degree of confidence and accuracy. And one must always consider that sample sizes are not necessarily limited and may not be representative of an ancient population. In ancient Egypt, tombs were often reused and became the site for intrusive burials. This is a tomb that I worked on in Egypt. It's the tomb of Nebwenenef. Nebwenenef was the first of Ramses II's high priests, and there were three altogether. And the tomb is dug into a mountainside, and all the way at the bottom is the actual burial chamber of the priest and his wife. But there are about 50 mummies of bodies that were placed in the tomb as intrusive burials. As a result, mummies that are found in any tomb may represent accumulations over anywhere from decades to centuries. Remember that mummification was done in Egypt until well into the Christian era, as late as the 4th century CE. The analysis of mummified material for ancient DNA has received a great deal of recent interest. And this is my friend Frank Rulli, who's the director of the University of Zurich's Institute for Evolutionary Medicine. And they've done an incredible amount of work studying ancient bodies. And they have an ancient DNA laboratory. And when you do any studies in DNA, it's very important to avoid contamination. In a modern laboratory, one has to be careful not to introduce DNA from people just walking by. So the ancient DNA laboratory has to have a higher air pressure inside it than outside. And you have to do this all under handling of clean room conditions. But in spite of all these difficulties, with the technical problems of the survival, first of all, of ancient DNA, and then avoiding contamination by modern DNA, laboratory applications can include the determination of genetic relationships, such as the remarkable recent clarification of the relationships among the members of King Tutankhamun's family. A potential negative aspect of mummy studies is criticism concerning alleged lack of respect for the sanctity of the dead. And we have to remember that such studies are conducted with the same dignity and scientific purpose as hospital-based post-mortem examinations of the recently deceased. The results of our mummy studies have given these ancient individuals importance and relevance to modern scientists and to the general public in very careful museum displays. And this is a picture of one of the mummies from a recent display at the British Museum, a mummy called Ginger. And he is ginger because his hair turned a reddish color, which is something we see frequently in these mummified bodies. Well, the topic that I'm talking about after that background information is learning from studying mummies. And the earliest period of interest in mummies might well be called the use and abuse of mummies. Mummies were powdered into drugs or exhibited as unrollings for the general public, for the paying public. This is Lord Lonsborough, and he unrolled mummies. A mummy from, this is 1850, a mummy from Thebes to be unrolled at 2:30, and it was 20 pounds. That's a great deal of money in 1850. Mummies were popularized by Hollywood in the horror movies of the 1930s. And I don't know, I hope that you have all seen or will be inspired to now go see Boris Karloff in The Mummy. I teach an Egyptology course at Villanova, and this is always the treat at the last class, is seeing this movie. The resurgence of interest in the examination of mummies that took place in the mid-20th century was led by the Paleopathology Association, a group of scientists representing various disciplines on Egyptian mummies. Pathologists at Virginia Commonwealth University, they've done a lot of work and continue to do work on Peruvian mummies, and Rosalie David's reactivation of the study of mummies in the Manchester Museum. It's not possible for me to review in this lecture the hundreds of mummy studies that have been published in recent years, or even the 100 or so mummies that I've examined. And I will focus on some historical and his theoretical issues and a bit of my personal experience in the field. When we started doing this, the actual dissection of a mummy would take 1 or 2 days, beginning with X-rays, followed by months of laboratory work with a comprehensive effort to focus the study on the interface of the physical, social, biological, and medical sciences, and publication of the findings as a final eventual result. And the progression of radiology from relatively basic X-rays to sophisticated computerized tomography, CT, and MRI, magnetic resonance imagery, has allowed non-destructive examinations and CT-guided endoscopic biopsies. So we can do CT studies and make small incisions and examine very specific sites of interest. And this is these X-ray techniques are done either before or actually instead of traditional autopsy procedures, which were often somewhat destructive nature. When we did autopsies on mummies, there really was not a whole lot left at the end. An example of this progress is the examination of Tutankhamun. In 1968, a portable X-ray machine was used to determine the age and cause of death of Tutankhamun. Loose bone fragments with the arrow pointing to it were found in the skull, and that led many to assume the king was murdered by a blow to the head, but the X-ray really couldn't support or discredit this theory. And when the body was restudied in the more recent past, it was found that the sternum, the bone right here in your chest, and most of the ribs were missing. And it was believed they might have been removed because they were badly damaged before his death. But it turns out that Howard Carter was not as careful as his personal notes had claimed. The mummy had not been rewrapped after the initial 1926 examination, which led to more deterioration. The limbs had been amputated, removed in order to remove some of the jewelry. The hands had been cut off, both legs were removed, and the head was severed from the body in order to get the mask off. And all of this was found in 2005 when Tutankhamun was removed from his tomb, which is down in Luxor, some 400 miles south of Cairo. And a CT scan was performed at the School of Medicine at Cairo University. So here is the mummy of Tutankhamun going into the CT machine. And this gentleman is Zahi Hawass, who you may know is a pretty famous Egyptologist, trained at the University of Pennsylvania, although he went through there long after I did. The scan allowed for accurate forensic reconstruction of his body and face, as well as further evidence of his cause of death. There was no traumatic injury to the head. That piece of bone that was in there is just something that broke off in the mummification process. He had a small cleft palate, and he had a very elongated shape of his skull, but that was within the normal range, and it appeared to be a family trait because this is shared with mummies found to be related to Tutankhamun. He was confirmed to be 19 years old at the time of his death, and the CT scan showed no radiologic evidence of any long-term disease, but more recent studies have indicated that he died of malaria. which is still a significant problem in Egypt. Well, one of the things we've found is that histologic examination of after rehydration of mummified tissues can demonstrate remarkable preservation of normal and diseased structures, but unfortunately, poorly preserved tissue tends simply to dissolve. And here's the feeling that you get when you have your test tube. You put your mummy's tissue in there, you rehydrate it, and in the morning, there's this little brown debris at the bottom. So what's the opposite of Eureka? However, we can use these special stains that demonstrate various parts of the tissues, as I mentioned previously. There have been two experimental approaches to the study of the effects of mummification. I was a director of the autopsy service at the Hospital University of Pennsylvania earlier in my career, and tissues that I removed from recently deceased individuals during hospital-based autopsies were desiccated. I bought a little oven and dried these tissues out at a pretty high temperature, so sort of simulating ancient Egypt. And I rehydrated them using Ruffer solution and examined them by light microscopy. Comparison between the fresh and the mummified tissues revealed variable preservation of histologic detail. The cytoplasmic structures, well, for those who are not familiar with histology, your cells have nuclei, and then everything else is called the cytoplasm. And the cytoplasmic structures were discernible, but the nuclei were very poorly preserved. The nuclei are where the genetic material is stored. An important point, however, was that when there's cancer, the nuclei are very large and stain very dark. And they turn out these large, dark staining nuclei of malignant cells were much better preserved than the smaller, lighter staining nuclei of benign cells, so that it bolstered our confidence in being able to identify cancer in ancient remains. The second major study, I'm sorry, the pictures don't belong there. Sorry. The second major study was performed in an effort to determine whether the appearance of the tissues of Egyptian mummies is due to the effects of the Egyptian mummification process alone, or is modified by the passage of the several millennia following the labors of the ancient embalmers. A donated adult male cadaver was mummified at the University of Maryland's Medical Center in Baltimore in a fashion as closely as possible approximating ancient methods. A royal mummification of the 18th dynasty was attempted using a replica handmade embalming board, copper, bronze, and obsidian tools, and with evisceration, removing the organs through a small left lower quadrant abdominal incision, the left lower part of the stomach, which is where the ancient embalmers would remove the organs. The evisceration of the body was performed using the same techniques, and the heart and the brain were not examined. In antiquity, the heart was left in the bodies as part of the funerary ritual. Slide. And the heart was weighed against the feather of truth. And if your heart was heavy with sin, you were going to the third level of the underworld, not a pleasant place to spend eternity. The brain was left in place because the function of the brain was unknown to the ancient Egyptians, so they simply discarded it. Linen packets of natron, which is basically sodium chloride and sodium carbonate, from the Wadi Natrun in Egypt, were used to pack the thoracic and abdominal cavities. Natron was placed under the body on the board, and the remainder of the natron was used to cover the body. The internal organs were removed and placed in ceramic dishes covered with natron and placed at the corners of the embalming board. The cadaver and organs were kept at 115 degrees Fahrenheit and 28% humidity for 35 days. Removal of the natron revealed a body appearing very similar to an ancient mummy, with fluid loss of almost exactly half the body weight. The separately desiccated internal organs were completely dehydrated. There was no evidence of decomposition or putrefaction or rotting. I examined specimens of the mummified organs without knowing the clinical history of the subject. The general state of preservation of the organs in this experimental mummy was comparable to that of actual 1800 to 3200-year-old Egyptian mummies, and small tissue specimens of the various organs were rehydrated and sectioned. The lung architecture was generally intact. A minimal amount of anthracotic pigment, this is carbon pigment, that's present in almost everybody's lungs just from breathing in pollutants in the air, smoke in the air. And some of the air spaces, the alveoli, contain pink material, which is a sign of pulmonary edema. Several large pulmonary arteries were seen to be filled with thrombus material, based clotted blood. Sections of the liver showed fine areas of scarring, and the kidneys showed evidence of old infection. So I was able to make diagnosis in this individual of several pathologic processes, including pulmonary edema, pulmonary thromboemboli, liver scarring, hepatic fibrosis, and chronic pyelonephritis, chronic kidney disease. So the first three of these were related to the death of this individual due to chronic congestive heart failure. And this, in fact, was what was documented clinically before he died, that he was in heart failure, fluid accumulated in his lungs, he had blood clots that formed in his legs and spread to his lung, and he had, because of the chronic heart failure, he had some scarring in his liver. So the result of this study is that Egyptian mummification practices were quite effective, and there was probably little further degradation over the centuries, with the exception of mechanical disruption by tomb robbers or attack by insects. And the preservation of most of the organs in this donated body was very similar to that of ancient mummies. Now, I've gotten involved in the program in biomedical archaeology at the K&H Center. And K&H is abbreviation for K. Hentley, who's funded the program in the University of Manchester. And this is a recently developed MSc program. And it's important, if you look at my notes, it's PROGRAMME. One has to learn British spelling if you're going to work with the Brits. And this has an emphasis, the program has an emphasis on biological Egyptology and focuses on the most recent advances, including the research for using technologies such as genomics and proteomics on mummified tissues. Covered our origins of the ancient Egyptians in relation to the Homo sapiens out of Africa event and subsequent migration of Homo sapiens into East Africa from Eurasia, using a route across the Sahara Desert that used to be much more fertile, and the Nile Valley. This program can be taken part-time or full-time. The cost of a Manchester online degree for extramural students is the same as for UK students. It's £9,800, which is about $13,000. The program is delivered completely online, which means that it's available to people who are working and is fully compatible with current pandemic restrictions. A wide range of additional topics, including studies of mummies from many areas of the world, is covered. And what you're looking at is my collection of over 3,000 slides that is now in the K&H Center. And I'll be able to give you just a few examples of my studies. So this is the lungs of a body that was some 2,000 years old, a frozen body that was found to have severe pulmonary anthracosis. This is a pretty much universal finding in ancient bodies because these are people who are exposed to open heating and cooking fires. You can see how black these lungs are. This is generally pretty innocuous in modern populations, except of course for the coal miners who get black lung disease because of their enormous exposure to this material. And here's a histologic picture of the lungs, and this particular individual were collapsed, and all of this black material in here is that anthracotic pigment, the carbon pigment. Tuberculosis is another ancient disease, and this is a figurine that I bought in Mexico, and we see here this poor person is a hunchback and has to actually use a cane to walk because the bones in the spine pinch the nerves and cause difficulty in walking. And this next slide is a 3,000-year-old Egyptian mummy. This was a small Egyptian child. In fact, when the archaeologist handed this to me, she said, "Here, this is a leg or something." You see, it's only about 20 centimeters long, about 1.5 feet long. I said, no, this is a small child. That's the hip bone of a child. And this unfortunate child had a severe curvature of the spine. Medical term is scoliosis. And there are only a couple of things that can cause this, especially in children. Rickets is one possibility, but rickets is due to lack of vitamin D, lack of exposure to sunlight. Little kids in Egypt don't have any problem being exposed to sunlight. They're running around without much way of clothing on. So the other issue is tuberculosis. And here, in fact, is a piece of bone from the spine of that child. And the arrow is pointing to a little red line, and that is a tubercle bacillus. That is the organism that causes tuberculosis. And not only were we able to identify tuberculosis in the bone, but a cause of death. This child had again, medical terminology, terminal hematosis, terminal loss of blood by coughing up blood from these damaged lungs in this child. I always call her her, although we don't really know the sex. But this is a section of the trachea. This is cartilage of the trachea. And these are all red blood cells in the opening of the open area, or the medical term lumen of the trachea. So this child died, basically bled to death because of tuberculosis. Another ancient disease is atherosclerosis, hardening of the arteries. And that's seen in these CT scans of royal mummies from the Cairo Museum. All these white areas are little bits of calcification. This is in the aorta. This is the spine, and this is in the aorta. And here is the knee, and this is the femoral artery. This is the femur, the big bone in your upper knee, upper leg. And this is the femoral artery, and there is atherosclerosis. This little bits of white material is actually calcification in the blood vessels. So atherosclerosis is an ancient disease. And we didn't think that this was true until these studies were done. The general feeling was that it was perhaps due to the diet of modern people or to the stress of modern life. I firmly believe that life has always been stressful, even for pharaohs. I worked with a Royal Ontario Museum, a Canadian expedition in the Dakhleh Oasis of Egypt's western desert. And these were some of the mummies, and they're out there on the beach. So I've got a container of sunscreen there for them, but they really don't need it at that point. And I examined about 10 mummies there. There are more mummies that other people have examined as well. And these were badly broken up by tomb robbers. Here we are in one of the tombs that were dug into the low hills surrounding the site. The site is an ancient, actually Christian town. Dates to the very early Christian period, about 200 CE. But you can see how badly broken up these mummies are. But two of them had cancer. And this is a microscopic sections. And you're about to get a quick lesson in microscopy and pathology. So this is the lining of the urinary bladder. This is the muscle wall. And this is a little outgrowth from the lining of the bladder. This is called can be called a papilloma. It's actually a very early form of bladder cancer. And over here, this is a section, so that's from the urinary bladder. And here is a section of the rectum, and there was a polypoid mass, a mass sticking up from the lining of the rectum. And not only is it sticking up, but it's also invading down into the muscle wall. So this is all the muscle wall of the rectum. And invasion means cancer. So we've got cancer of the bladder, cancer of the rectum. There are very few cancers found in any ancient bodies. There are a number of skeletons that have holes in them, but you can't really do microscopy on a hole. It's like eating a hole in a donut. So there are only 2 or 3 actually documented cancers in all of these ancient remains. And Dr. David and I actually wrote a paper that was published in Nature about cancer, an ancient disease, a modern disease, or something else, something in between. So, and as you can see from the this list of the lectures that I have done and I'm doing for the K&H Center on my next trip to England, which has been postponed 3 times because of the pandemic, and things are still pretty locked down. So I'm hoping to go back in January and complete these lectures. But the program is now expanded well beyond the sands of ancient Egypt. So this is my opening little talk about how I became a paleopathologist, and notice the British spelling of paleo with an A. The Iceman, I was involved in studying the Iceman. I've studied Antarctic seals and the possible role that they played in spreading tuberculosis from Africa to South America. Elmer McCurdy was an American bandit who died and was embalmed in arsenic in the early 20th century. And many of his tissues were preserved. Head of state, I was involved in studying the Kennedy assassination and other heads. I've examined heads of other individuals. And then just general lectures on basically the first 2 years of medical school, forensic anthropology, human evolution. I was involved in studying the sinking of the Swedish ship Vasa, study the helmsman of the Vasa, who developed the severe damage to his elbows from steering these very difficult ships. And pretty much what you've heard about here: why do we study mummies? How do we study mummies? And the history of plagues, and the British Museum mummy exhibit, a wonderful exhibit that has been now been closed for a couple of years. So if you'd like to do more reading on this topic, here comes my fearless advertisement, my new book, My Patience for Mummies. It's available from Amazon, but I regret to tell you that it's unfortunately pretty expensive. But I do have this book available, and I would like to thank you for your I'd like to thank you for your attention. So, okay, folks, it's a wrap. Thank you again.
Thank you so much, Dr. Zimmerman, for giving us a very different insight into ancient Egyptian mummies from a medical perspective, which is a little bit different from what I study, which is more, cultural, archaeological. We get the science, but it's a different kind of science. Let's just put it that way. If you have any questions, put those questions, please, in the Q&A or in the chat, and I will, Maria and I will be looking for those questions. All right, we already have some questions that have come up. Let me see quickly. I'm looking at a different document. I wish I had like 5 different screens to get all this done. All right. Okay, so we have one here from Dr. Rachel Lance. What are the specific signs seen on the mummy that indicate death by malaria?
Well, the only thing that we can see in mummies that suggests this is that they have damage to the spleen. There'd be enlargement of the spleen. But there are some DNA studies that suggest this possibility. And let me just say to Rachel, hello, because I read Rachel's book on the Hundley. And so we've been corresponding back and forth, and I'm glad to see that you're able to attend this lecture.
Excellent, thank you. I have another question here from Deanna Wynn, who asks why there is so little evidence of cancer been found. Was the incidence of cancer lower in ancient Egypt than it is now?
And that's a really easy question to answer. They didn't smoke. That's certainly the leading cause of cancer in modern society. And that, of course, is a 20th century phenomenon. You know, people didn't die of cancer in the 19th, 18th, 19th century. You know, they mostly died of infectious diseases. But the smoking epidemic has caused our modern incidence of cancer. We find a few examples, but very, very few. And it's all about the penalty of modern life, living with cancer because of smoking.
Thank you for that answer. I have a couple of other questions that are sort of the same.
Oh, maybe I shouldn't have brought that up, considering the Duke is right down the street. And that's where all their money comes from.
From an anonymous attendee, what is the most unusual or shocking discovery you've ever made when looking at a mummy?
Well, one of the most unusual things was that I was invited to the Museum of Natural History in New York, and I examined the remains, mummified remains of a mammoth that had died over 20,000 years ago, and there was still preserved histologic structure in this mummy. So these features can live for many, many years. I don't know, I've done so many things, it's hard to think of any one thing, but certainly all of the frozen bodies that I've seen in Alaska, because I examined the remains of an entire family that were crushed by ice coming into the area of Barrow, and they sadly all died at the same time of this very sad, very something that made you really feel for this family.
Yeah, it's interesting that you do both. I mean, human remains, whether they're mummified by the sand or with with technologies, or if it's in the ice. A human is a human, basically. So you can study all these humans. I see loads of questions. Let's see if we can get, we have a question here from a colleague, Helen Dixon. Hello, Helen. Can you talk a little bit more about lung tissue slides? Do you have theories about the origin of the carbon from fires, incense, or other substance?
It's pretty clearly from heating and cooking fires. You know, even it's Egypt and it's cold and it gets down, doesn't get ever down to freezing, but it's cool in the evening. It's a desert. And if any of you spend any time in the desert, you know, it gets cold at night. So they have to have heating fire, and the fires are open fires. And the houses are full of smoke. And that's where that carbon pigment comes from.
Thank you. I have another question here. What was the most common cause of death for the pharaohs or the Egyptians? Violence, nutritional disease, arteriosclerosis, or infection?
The most common,
multiple choice.
well, the most common cause of death for the ancient populations in general was infection of various sorts, and things like tuberculosis, parasitic infestations, particularly. Schistosomiasis is a parasite that gets into the intestinal tract, and it lives there for the individual as long as the individual stays alive. And it's kind of a love story. The female worm is bigger than the male, and she wraps herself around the male, and they spend 20, 30 years in there making little baby schistosomes. But because they're hooked into the intestine, they cause a severe degree of intestinal bleeding. And the ancient Egyptians and modern Egyptians are, as a result, anemic, and this can cause death. And also, some of the eggs that they produce, instead of passing out through the intestinal tract or the urinary tract, they affect both, can wander up into the liver and destroy the liver. So it's a very common cause of death and disease, even in modern Egypt. In fact, half of all young men who are examined for the military in Egypt get rejected because of schistosomiasis and anemia. So it's still a huge problem in the Middle East in general. There's a form in the Far East as well.
Thank you. I saw comments like, oh, it's like parasite love story. Where do you see the field of Egyptology heading in the next 10 years? Which technologies will be applied to further the field? And I'm thinking mummy studies more than Egyptology in general.
I think that DNA studies are going to continue to be more and more important. MRIs. Right now, magnetic resonance imagery is an incredibly useful field for modern clinicians. It's more difficult for mummies because it depends on the agitation of water molecules, and mummies don't have much in the way of water molecules. But new techniques for using MRIs to examine mummies are being developed, particularly by as pointed out, my colleague Frank Rulli in the University of Zurich. And I think that that's going to be a field that's going to be even more used even more, because the future is certainly not in doing what we did when I started examining mummies, which was basically taking them apart and examining tissues from everywhere in the body. We're going to be doing very much more directed studies, and we're going to get better results as well. And at the same time, preserve those bodies both as museum objects and as people who deserve all respect.
Thank you. I have a quick question here. How do you determine damage from before death or after death? Let's say a broken bone. How do you know a broken bone from before or after death?
Well, first of all, the major evidence for any damage that's done before death is that if there's healing. If you see evidence of healing, then you know it happened before death. If there's no healing, then you either feel that this happened at the time of death or sometime after death. And the third way is if you find a weapon in the site, and that's been found. You know, we find that. We find bones with knives with spearheads stuck in them. So we know that that happened at the time of death. So, and I'm trying to think of this one other. Oh, I think that's basically it. That if you find healing, oh yeah, there's some recent studies of the pharaoh's second Enra, and
yes,
they're claiming now that he was tortured, but his skull shows signs of healing. So he survived sometime after. He's the one who drove the Hyksos out of Egypt, and there's evidence of healing on his skull. So he certainly survived for some period of time after the battle that he was in. And I really don't believe that he was captured, tortured, and murdered. I think he survived and was taken care of for a while and then expired. But the basic answer is if you find healing, you know that these injuries occurred before death.
Yes, and second Enra, that was recently again in the news earlier this week or last week. So if people are wondering about that. Here, a question about parasites. have the parasites or bacteria evolved over time, or are they identical to current strains?
They're all pretty much the same, the schistosomes. But why would a parasite evolve? A parasite would only evolve if it had reached a point where it was killing its host. It's not in a parasite's best interest to kill its host. Then it's got to go find a new host. So if it can make its livelihood inside the host, get whatever it needs, and yet keep the host alive, then it has no incentive to change. Whereas if it will kill the host, then it's got an incentive to change. And that is something that we're actually seeing now with the coronavirus, is that it's killing many of its hosts, and all these variants are occurring because it doesn't want to kill its host. It wants to keep them alive so that it can just keep on living inside the host. So that's one of the basic rules. But life is a constant battle, and we are evolving. Humans are evolving, and parasites are evolving too.
Indeed. In ancient times, where would the Egyptians pick up these parasites from? Water, for example? That's one of the questions from Allison.
Good question, and it's because of the life cycle of the schistosome. The schistosome produces eggs either in the urinary bladder or in the intestinal tract, and then it's passed from there into water. The eggs hatch, they develop into a secondary form of that, and I won't burden you with the name of these forms, but that secondary form then invades an aquatic snail, and it matures into yet another form that hatches out of the snail and is infective for humans. And when humans go into the water, those infective forms go through the skin, into the skin, find their way into the intestinal tract or the urinary tract, and make their new home there. And and why are Egyptians in the water? I have a beautiful picture of the Nile at sunset with feluccas sailing in the Nile. It's a lovely picture, but there's a man squatting in the water on the edge. And when you don't have indoor plumbing, that's what you do. You go to the river, you go to the Nile, and you excrete things into the water. And then also the Egyptian agriculture system was dependent on the flood of the Nile, and the fields will be flooded. People will go out into the fields to plant and then eventually to harvest, and they would be in the water. And we're seeing the same thing actually now up in the Delta, where there's so much malaria, and people are in the water. The mosquitoes hatch in the water, and then they spread malaria. So it's all in the water.
It's all in the water.
Stay out of the
one
water.
more question, talking about water and melting things, from Linda, who says, never thought about this, but do you find more frozen, in quotes, examples of more examples now, which might be an indicator of global warming?
That's certainly true. As I mentioned with I didn't tell you about I didn't tell this audience about my student at Columbia University. Excuse me, let me get a drink of water.
I'll have one too.
There was an outbreak of anthrax, a severe bacterial disease in Siberia about 5 years ago. And I was not involved in studying that directly. I have a student at Columbia University who's getting a master's degree in fine arts and she's producing a movie script about that anthrax outbreak. And the reason it occurred is because the caribou, basically the kind of deer that live up in the Arctic, they got anthrax. They got this terrible disease and died and fell into the permafrost and their bodies were frozen. They were covered with snow, and then they were frozen and became embedded in the permafrost. The permafrost is melting now, and those bodies popped out of the permafrost and caused this anthrax epidemic. So we are seeing the result of climate change. I brought my family to Alaska, not just on a trip 2 years ago. Last year was a lost year. And we went to see a glacier in Alaska. Excuse me. And the park ranger came to me and said, "Wow, isn't this an incredible sight?" And I said to her, "You know, I was here 25, 30 years ago, and it was 3 times this big." And to me, it's just sad to see that these glaciers are shrinking.
Well, thank you so much once again for sharing your experiences with us studying mummies in many ways that most Egyptologists don't get to study mummies. I'd like to thank also all our participants for attending today's Weinberg lecture. We'll see you again next year. Next year is 2022, the anniversary of the discovery of Tutankhamun. So I'll try to see if I can get something related to King Tut for next year. But thank you again, Dr. Zimmerman, for this wonderful lecture on learning from ancient Egyptian mummies. And do let us know, let me know when you're in North Carolina to see your daughter and like to meet up again with you.
I'll be there frequently. Thank you. Thank you very much. It was my pleasure.
Thank you everyone for being part of this lecture. I'd also like to thank Dr. Zimmerman for such a fascinating lecture. Thank Dr. Hillings for her wonderful introduction, and Caroline Rochelot for being such a fantastic moderator for a Q&A session. And we hope that those of you who are in North Carolina can come and safely visit the exhibition. And just as a reminder, we will post the recording of the lecture on YouTube and share it with everybody. And we also want to thank everybody for their patience with their technical difficulties, but we were able to figure it out. And also let's virtually give Dr. Zimmerman a round of applause for his great lecture. Thank you very much again, Dr. Zimmerman.
Okay, thank you, Maria. It's my pleasure, as I said.
Thank you,
Thanks,
everyone.
everyone.
Okay, bye-bye.